Hi again. So I continue on the lesson. Prime numbers, a number that has exactly two factors, which is itself and 1. So they are prime numbers. The first prime numbers is 2. So what do I mean here? So 2 is just 2 times 1, and I cannot write it in another way. So that's a prime number. 3 is prime number because it has 3 and just 1. Okay, so those are the factors. If I can just factor, if I can break the numbers to different numbers, and I can't for 3. But how about 4? 4 is 2 times 2, 4 is 4 times 1. So 1, 2, 4, they are factors of that just number 4. So I cannot, so I say 4 is not a prime number. Okay, so 5 is prime number, 6 is not because it's 2 multiple 3, 7 is prime number, 8 is not because it's 2 times 4, and 1 times 8, and 2 multiple 2 and multiple 2, so 2 power 3 is 8, and also 9 is not, and 10 is not, and again 11 yes, and again 13 yes, 12 no. Okay, so when I cannot break the numbers to different factors rather than just itself and 1, then if I can't, I say that's a prime number. If I cannot break it, just 1 and itself, yes, that's okay, but other numbers, no. So that's prime numbers. Here, composite numbers. So again, I don't know what's wrong when I just, okay, so I have to, yeah. Composite numbers are just not prime numbers when I can break them to different numbers rather than just 1 and itself. For example, the same as 4, because 4 is, so I can break that to 2 times 2. I can do 6, 2 times 3. I can do 8, 2 power 3. Okay, so not just 8 times 1. 8 times 1 is 8, I know, but I have other choices. Okay, so they are composite numbers, right? So, what are some other composite numbers? I wrote them here. Okay, so even numbers, odd numbers, even numbers, they just are multiple of 2. Okay, so even numbers like 2, 4, 6, 8, 10. So these are even numbers, and odd numbers 1, 3, they are not divisible by 2. I cannot divide them by 2. I have just a leftover. Okay, so 1, 3, 5, 7. So some books, they also consider negative numbers as just negative, negative 2, negative 4. They are just saying that they are even numbers, and also -1, -3 for odd numbers. Okay, exact numbers. Exact numbers are those numbers that we are certain about them. Okay, so numbers that we are certain about them. Numbers which we are certain about them, or just certain numbers. Okay, they don't have any uncertainty. Okay, certain about them. For example, if I say a car has 4 tires, 1, 2, 3, 4, I can count them. If I say I have 3 gifts for you, I have 2 gifts for someone, so that's, I can count it, 1, 2. If I say I have 30 students in my class, I can count them. That's exact numbers. Okay, so for example, 4 tires in a car. 3 gifts, for example. Number of gifts. Number of students. Because I can count you. Okay, so I can count number of students, so that's, but approximate numbers, we measure them. If we measure something, if you measure the, for example, the desk, the table that you are just sitting at to watch this video, so it depends on the scale you are using. Maybe you have just a scale which just shows you centimeter, maybe no, you can use another scale and it shows up to millimeter. So it's approximate when you measure. So measured values, they are approximate. Okay, so if I have a measured number, so I can type it here. Measured values. So you have many measured values in the lab. They are approximate because you use a, when you do something, weight, grams, kilogram, when you do volume, meter, liter, milliliter, when you use length, meter, centimeter, those are, when we measure something, they are approximate. Okay, so when I say, for example, 3 gram or 3 grams, so when we measure numbers that we are not certain about them, I can say, I'm not certain about them. Okay, I'm not sure about them. So they are just approximate numbers. So symbols, I can show these symbols. Of course, you know this is equal, this is not equal, and this is approximate. Approximate is this. Less than, more than, less than or equal to. So, see, if I say A is less than B, I show it this way. And remember, sometimes I see a student, they say, when they read this, they say B is more than A. I know it is, but I read from left to right. Okay? So I tell them, show me A less than B. So they show this way. A is less than B. Okay? Yes, I know, but I just read from left to right. Okay? So less than. So A is more than B. I show it this way. A is less than or equal. A is less than B or A equal B. So I show this A less than or equal B. Or means any of them can be correct. In math, when I say or, the statement is true if one of them is correct. If less than or equal. Of course, cannot be both. Cannot be less than and equal. So I see many students, when they read this, they say less than and equal. So I don't reduce mark, but that's wrong. I have to say or because it's impossible to have both of them. A more than and equal. So more than or, sorry, I said and, more than or equal. So I can show you this way. Okay? So it's or because impossible to have both of them. Okay, but both of them, any of them can be true and the statement is true. But here, for example, if A is less than B, is not true then because sorry, if A is equal B is not true then. Just less than B works here. Here just more than B works here. But for the next one, less than B or equal, less than or more than B or equal. Okay? So this symbol, we call it radical. The number or the radical is radicand. So if I have radical, for example, 4, I have this one as radical, this one as radicand. Okay? And what is the answer? Many students, they say answer of this is plus minus 2. And when I ask why my calculator doesn't show me minus, they say our calculator just show positive. That's wrong. Okay? Radical 4 is just plus 2, not minus. Okay? So radical 4 is just 2. And what is the reason? I can show you the reason here. Okay? Please watch this. Okay. If I say, I see this mistake many times. I see even teachers, they make this mistake. And I accept. I don't argue, and I give you full mark if you do. So radical 4 is plus minus 2. But I want to explain this here. If I say in language, just in English, in any language, if I just say what is a square, sorry, square root of 4, you can say plus 2 minus 2. I say why? Because plus 2 times plus 2 is 4, and minus 2 times minus 2 is also 4. Yes. So if I say in another language, so when I write the sentence, you can answer plus minus 2. But when I use radical, I define. Look at this. This is from your book. Not your book, but in another book. But also your book has that. Okay, so it's even page 20 in your book, so you can check it online. See? Where is it? So here, we definition. When we define, we accept it. We define principal root, which is radical, to be positive. So I use the symbol. Principal root here, the notation of principal root is radical. Okay? I use the symbol. So if I say what is the square root of 4, yes, you can say plus minus 2, because both of them, when I square, is 4. When I square 2 is 4. Yes, I know both of them. But when I say what is radical 4, because mathematically I define this symbol to be just positive. So I don't accept the negative here because I define this symbol to be positive. Look at here. Look at this. We define the principal square root to be positive. And here, general notation of principal n root, or I can say, for example, second root is just radical. And radical means radical 4 is just radical 4, 2 here. Okay? I don't show 2. If I just show radical 4 means just root 2, but I don't show it. I define this symbol to be positive. So that's why I say just 2. And that's why I say this is wrong. That's why I say when I ask radical 4 and a student say plus minus 2, yes, I know. We even hear it from teachers, but that's not correct. But if I see you make this mistake, I don't reduce mark. And I just want you to know it, that radical is defined to be positive. That's symbol of radical. So it's defined to be positive. So I understand minus 2 square is 4. 2 square is also 4. Both of them are 4. If I ask you what is the square root of 4, yes, you can say plus minus. But when I say radical, answer is positive. So that's why when you use your calculator, radical 4 is 2, radical 9 is 3, radical 16 is 4, radical 25 is 5, and you can go on. Yeah. Okay. So multiplying integers. So I can show different symbols for multiple. I can show this as for multiple. I can show dot as multiple. I can show 2 brackets beside each other, and that means multiple. And I can show these stars. These stars, we use them in computer language. In computer language, we use them, and they are all multiple. So you don't see stars because we don't write to computer language here in math. You see multiple or dot or 2 brackets beside each other. It means you are multiplying 2 brackets or multiplying 2 numbers or multiplying 2 results from the bracket. Okay, so what does parentheses mean? If you are a student of Bachelor of Mathematics, parentheses and brackets and braces, they have different meanings, but for you, they are just grouping symbol. I am grouping them. I have 4 plus 3 in a bracket or a parenthesis or a brace. It's the same meaning the same meaning. So this is, I have to finish inside the parenthesis. So 7, and the other one 7. Yes, I have to find the result. Means I group them. Here, what's that? It's 3 times 7 minus 4, which is 3 times 3, and which is 9. Okay, the other one as well. So, but I didn't teach you order of operation, so I don't talk about these things here. I have to show you order of operation, and I do this in future. Okay, we can come back here later. Special properties, commutative properties. If I talk too much, I cough, so I don't have any problem with COVID-19. So here, addition and multiplication. When you change the order, you don't change the result. So we say it's commutative. Means A plus B is the same as B plus A, and A multiple B is the same as B multiple A, but it doesn't work for the subtraction. A minus B is not the same as B minus A. A divided by B is not the same as B divided by A. No, it's not. It doesn't work. Just for multiplication and addition. Associative properties, so applies only to addition and multiplication. So means, for example, if I have group in addition, so it doesn't matter. When I have all addition, I just add them. Okay, so here, for example, it means this one plus this one plus this one is the same as this one plus this one and this one. So because it's just addition, so it doesn't matter if I use the grouping if I don't, because just add them all. And for multiplication, the same as well, because it's just multiple. But if I say, for example, one of them multiple, one of them division, it's different if I use the grouping symbol for just in different order. It's not the same. For example, if I say, so, for example, if I say this minus this, and if I say, for example, let me see. So here, this, they are not the same. Okay, so it just works for, so we just learn this when we talk about order of operations. So we learn all of these. Okay, so distributive property is used to remove grouping symbols. I can distribute a number before a bracket. When I distribute, again, I need to teach you order of operation, and then all of them will be resolved, and you learn all of these if I teach you order of operation. So distributive property is used to remove grouping symbols. When you want to distribute, you have to just distribute the number inside the bracket. You have to multiply. So this is 15. This is 15 plus 6. This is 3a plus 3b. Okay, we have to multiply. But again, if I teach you order of operation, then you will learn this. I don't need to show you as a different lesson, different topic. Factors versus product versus quotient. Okay, 3 and 5 are factors of 15, because when I break 15, I can break it to two numbers. They are factors. So here I can say 3 and 5 are factors of 15, because if I can break 15, 3 multiple 5. Product means multiplication, and quotient is the result. Quotient doesn't mean division. No, quotient is the result. 4 divided by 5, I can use my calculator. It is 0.8. 0.8 is quotient. Quotient is the result. Quotient. So if I say quotient of 4 and 5, it doesn't mean 4 over 5. No, quotient is the result of 4 over 5, which is 0.8. Quotient is result of division. How about here? 0 in the quotient, so 0 in 0 means in the division. So here, so I talked about this before. If I have 0 divided by 20, for example, you can remember this. If I have 0 pizza and I want to divide it between all of you, you don't get anything. So you get nothing. So 0 divided by 20 is 0. Nothing divided by many people. Nothing divided by many shares, 0, because I have nothing. But if I divide 20 between zeros, so it doesn't make any sense. So I say it's undefined. Again, I have to emphasize, don't say plus minus negative. It shows you know a little bit of calculus. That's in limit. That's just different. See, if I say A over B and I say B is approaching to 0, then I say infinity or minus infinity. But if I have exactly 0 in the denominator, it's undefined. We will talk about that future in Math 273. You will see it there. Okay? And so I did this. Reciprocal. Reciprocal means you just flip it. Reciprocal of 3 over 4 is 4 over 3. So reciprocal of 3 is, you have to say, okay, it's reciprocal 3 over 1. When I don't say I have 1 in the denominator. So it is 1 over 3. Reciprocal of 1 over 3 is just 3 because you make it 3 over 1, which is 3. Reciprocal is when you flip them. Okay. Practice. Represent 5 plus the product of 7 and 4 using mathematical symbols. Okay, so 5 plus product 7 and 4. You have to show it this way. How do we solve it? We can come back later when we learn about BEDMAS. Using distribute property, calculate this. Using BEDMAS, you calculate it differently, but it says distributive property. So I have to say 5 times 7 minus 5 times 3. I distribute it. So it is 35 minus 15, which is 20. But from the very first place, I can say 7 minus 3 is 4, and 5 times 4 is 20, and I want you to do that when I teach you BEDMAS. We want to follow BEDMAS every time. So use this property, just show me, okay, so this is just because it's all plus, so I can do this. Or I can do this. What is the result? 12. Done. Okay, because they're all plus. Okay? What is the reciprocal of that? That's a very good question. Very, very good question. Many times when I say what is reciprocal of this, a student, they say it's 1 7 over 5. Wrong. What should I do? I have to treat this as a fraction. Of course, this is not a good question here because we didn't teach you fraction, but here I can say, and then we can talk about fraction later. I know it doesn't make any sense, but remember, reciprocal of 1 5 over 7, I have to calculate. This is 1 complete pizza, and from the second pizza, I have 5 over 7, means I divided between 7 and I use 5 parts. I divided between 7 equal parts and I use 5 parts. So this is reciprocal. I talk about it later in fraction, but this is 1 times 7 plus 5 over 7, which is reciprocal 12 over 7, which is 7 over 12. I use reciprocal here. Remember, reciprocal doesn't mean you just flip it. No. Here, I have to first go to fraction. From mixed fraction, I go to fraction. And then I flip it. This is mixed fraction because I have complete 1. And then from the second one, I use 5 over 7. Yes. So Signed numbers, positive, negative numbers. Okay, for example, I can show you this example. The example is a word problem. I can talk about word problems now, or I can talk about word problems later. So when you see a word problem, you have to read it first and understand the question. Then you can say, what type of question is that? Okay, you have worked all summer to help pay for college tuition. Checks and bills. Checks are coming to your account, bills are going from your account. So I can say checks are positive, bills are negative. But I recommend read the question first and then go back and translate. You have to read the question first. You have to understand what is the question, what is the type, and then you can go back and just translate and answer and find the answer and then check your answer and just check your answer if it's correct, and then it's done. At the end, you have to write a conclusion. Conclusion doesn't mean you say answer is this. No, you have to write a conclusion in just informative way that I see what was the question. You have to show me you understand the question. Here, we want to just show you sign numbers. Okay, so I just tell you checks are positive, bills are negative. Okay, you have you worked all the summer and you made $9,000 plus $9,000 coming to my account. Last paycheck is $1,000, so means I still, the company which I worked for all summer, they owe me, and just they paid. College tuition fee, which right these days is more than this, it's $2,000, so negative because it's going from your account. Your employer overpaid you and they made a mistake and you have to give them back, so it's minus 500 because it's going from your account. The college granted you a bursary, so you applied for a bursary maybe, and they gave you this, so it came to your account. Then you just find the answer. So it says what is the account balance? Okay, the account balance is 9,000. So I can show it here. 9,000 plus 1,000 is 10,000. Minus 2,000 is 8,000. Minus 500, 7,500. And sorry, and I have to pay. I have to receive money from college, so it's just 10,000. So 8,000 and 500 going, 500 coming. So it's just $8,000. 8,000 is in my account. Remember, when you have a word problem like this, read the question first, understand the type. Here the type is just plus minus, positive, negative. So that's why I made positive, negative. So I have to read the question, I understand the type. I have to read it second time and just translate math language. Okay, so math language here says, okay, so I have a check, I consider positive, I have a bill, I consider negative, and then I add them all, and then at the end I have to write a sentence. The sentence cannot be, the answer is $8,000. Come on, what does it mean? You have to say, my account balance after all these transactions, for example, is $8,000. The answer must be informative enough that I know what was going on. So here I know it was a just calculation of plus minus positive negative numbers. It's talking about money. I can understand. Your answer must have a unit. What? 8,000 what? 8,000 hours? Or 8,000 pounds? Or $8,000? This is unit. You have to show me the unit as well. When you have a word problem, read the question first, understand the type, go back, read it second time, and translate to math language. The math language here says check plus and bill minus, and then I can calculate easily. I don't make mistake here because I have plus minus, so I just add them. 9 plus 1 is 10, and then 10 minus 2 is 8, and 8 minus, so just half, because it's half a thousand, so 7.5, and again plus half, so $8,000. Okay, and then at the end I need to write a sentence. The sentence should be informative. The sentence should have enough information, necessary information, and the sentence should have unit. Okay, so how about here? Same signs. So if the numbers are in same signs and I want to add them, so I just add them. For example, here, what is 2 plus 3? So I just add them. That's it. That's 5. How do I show it on number line? On number line, I do this. Maybe I use this to make it more beautiful. Okay, so I find 2. So here is 0. Here is 1, and here is 2. I have to consider that if I need to show negative part here, no, I don't, because it's 2, and then I go plus 3. Means I have 2, and then I move 3 to right. 1, so I find 2, and then I do 1, and then I do 2, and then I do 3. My destination is my answer. I start from 2, because it's plus 3, I go 3 units to right. 3 to right. And the destination is the answer. So if I tell you, which I'm going to tell you, week 2 that you have quiz, I want you to show me, but with number line, I want you to show me this way. The destination is the answer. Okay? So how about this? How about this one? Okay, I have 2 negative numbers. The rule is when you have 2 negative numbers, just add them and the result is negative. That's it. If you have 2 positive, just add them. If you have 2 negative, just add them, but the result is negative. So what is the result? Okay, 2 plus 3 is 5, but I have negative, so it's minus 5. Okay? How about here? Okay, so I can find, okay, I use this. I find minus 2. So here is 0. I find minus 1. I find minus 2. Equal space, so minus 2. Then it says minus 3. So I go 3 units to left. Don't say I go minus 3 units. Doesn't make any sense. When I move positive. But right shows me negative, left shows me, right shows me positive, left negative. Okay, so because it's minus 3, I go this way, left. 1, 2, and 3. Okay, what is the destination? Minus 1, minus 2, minus 3, minus 4, minus 5 is the destination. Minus 5 is the answer. So if I ask you show me with number lines, I want you to see that. If I say I want to see with number lines and I don't want to see a scaling, means I don't really mind that you show me equal space between 2 numbers. Okay? Here I have a space, so I do it. How about different signs? If I have different signs, what do I do? If I have different signs, I find the difference between 2 numbers, then I use the sign of bigger number. 5 and 6. What is the difference between 5 and 6? 1. But what is sign of bigger number? Sign of bigger number is sign of 6 because 6 is bigger. And sign of 6 is negative. So the answer is minus 1. How about minus 7 and 2? Okay, 7 and 2. What is the difference? 5. Between 7 and 2, 5. What is the result? Minus 5. Why? Because my bigger number, which is 7, has negative sign. So I use minus 5. So I find the difference and then I use sign of the bigger number. I find the difference and then I use sign of the bigger number. Okay? How do I show a number line? I do this in next video. Thank you so much.